All right, now we're on unit 6. So we're finally to integration. So what this first one wants, it wants us to do a left Riemann sum with 4 subintervals. So left means we're going to start at the left. And I'm going to use these intervals right here. So by starting at the left, I'm going to just start with this y value. So it's going to be 2 times the change in between 0 and 2, which is 2. Then I move to the next y value, which is 4. The change from 2 to 4 is 2. Next y value is 1. Change from 4 to 7 is 3. Then I have 8. Change from 7 to 10 is 3. So we just need to go ahead and figure out what this equals. So 4 plus 8 plus 3 plus 24. If you add all of those together, you should get 39, which is D. I don't know why that took me so long. Next, so this one wants a midpoint Riemann sum. So we can only have 2 equal subintervals because we have to have some middle value. So this is what we're going to be using for our middle values, but our change is going to be from 1 to 9 and 9 to 17. So we're going to have 3, because that's our middle y value. The change from 1 to 9 is 8, plus our next midpoint y value is 2. The change from 9 to 17 is 8. So we should have 24 plus 16 should be 40. All right, 103, trapezoidal sum. So this one is going to be the trapezoid formula, which is base 1 plus base 2 times height divided by 2. So looking at this, our first base is going to be 2. Your bases should always be your y values. Plus 1. Your height's the change, so from 4 to 7 is 3 divided by 2. Then we keep going. So I'm going to reuse 1 plus 4. Change from 7 to 8 is 1. Then from 4 plus 3. Change from 8 to 11 is 3 over 2. And then I just have to do the math, so it's going to be 3 times 3 is 9 halves plus 5 halves plus 21 halves. And if you add all those together, you should get 35 halves, which is 17.5, or C. All right, next, we have an increasing concave down function. So that's going to look something like this. And it wants to know which of these is an under approximation of the true value. So if I have a left Riemann sum, that's going to look like that. So if we look at that, that's obviously an under approximation. So it has to be at least 1. So it can't be B or D. Next, if I look at a right Riemann sum, let me erase all that. So again, it's 1. Drawing these lines, you can see those are an over approximation. So it's not 2. That really doesn't help us though. Now I got to figure out about the trapezoidal. So trapezoidal, as you can see, that one is also an under approximation. So 3 also. Our answer is C. 105 is like number 30 on the mock. Just gonna no. I mean, if you're curious, the answer I believe is B. I honestly have no idea. All right, so they give us f of x equals that function, and then they want the derivative. So f prime of x is going to equal d dx. And then based on the second fundamental theorem, we know that we're just going to replace the t with x's. So f prime of x just is going to equal cosine of x minus 3. So your answer is B. (107) differentiable function. We're looking for f prime of 1, so very similar to the last one. So we're essentially going to just replace t with whatever our function is at top. So it's going to be 2x to the power of 3. But since this is not just x, we have to multiply by the derivative of this function, which is 2. And then I'm looking for f prime of 1. So I'm going to just replace the x with the 1. So 2 times 1 to the third power times 2, which is 8 times 2. Your answer should be 16. All right, now we're trying to figure out where f is increasing. So we need to find the critical points. So f of x is going to equal the derivative of our integral. So basically f prime of x is just going to equal x squared. So if I set that equal to 0, obviously the only value to make that would be 0. Set up a thing here, so f prime, f. And then we'll just plug it into the derivative. So I need to figure out, let's see, if I plugged in a -1, it's going to be positive. And if I plugged in a positive 1, it's still going to be positive. So basically, this is increasing everywhere. It's going to be C. Okay, here I need a point of inflection. So first derivative. Again, same rule is going to apply. So when I take the derivative of that integral, it's just going to become 2x minus 4x squared. Second derivative is going to be 2 minus 8x. Set that equal to 0. And we get 8x equals 2. So x is going to be 1/4. Now we need to make sure that's a point of inflection. So we're going to plug in a value to the left. So let's say I plug in 0. I should end up with a positive number. And if I plugged in 1, I should end up with a negative number. So it will be changing from concave up to concave down. So 1/4 will be our answer, or A. Okay, here we have this function. I'm going to go ahead and split this one up. So it's going to be the integral from 1 to 8 of f of x plus the integral of 1 to 8 of 2 dx. But first, let's go ahead and find from 1 to 8. So we know we're going from 1 to 8. This one's in the wrong order. So really the integral from 1 to 5, f of x, should equal -2. So from 1 to 5 is -2. From 5 to 8 is 3. that makes the entire thing equal to 1. So this equals 1, but now I have to think about this one here. So it's going from 1 to 8, and our equation is 2. And if you remember, these just make a rectangle. So from 1 to 8, it's going to be 7, times the height is 2, so I get 15. So that special rule, you multiply the change from 1 to 8, which is 7, times this number. That's what gives you this 14. Add 1, you get 15. All right, another one. So always draw this picture. We're going from 3 to 9. So from 3 to 5, we know it's going to be -4. This is in the wrong order. So from 3 to 9 should be equal to -5. And we went from 5 to 9. So let's just make an equation here. -4 plus x equals -5. So x should equal -1, or b. Okay, here we have the piecewise function. Looking at this, we need to evaluate the integral from -2 to 0 of g prime of x. So notice we have g prime here, and we have g. Those do not match, so it's not going to be area under the curve. We need to set it up with the first fundamental theorem of calculus. So that's going to equal g of 0 minus g of -2. So really, when I'm evaluating this, it's just going to equal g of 0 minus g of -2. And I'm just going to find these from the graph because it's just the y values. So g of 0 is just 0. G of -2 is 2. These come from the y values. So our answer here is -2, or A. All right, 113, we need the integral from 1 to 4 of x plus 3 over x. For this, we should really just split it up to x over x plus 3 over x, which simplifies to 1 plus 3 over x. Then I can take the antiderivative, which ends up being x plus 3 natural log of x, evaluated from 1 to 4. And then I just plug it in. So 4 plus 3 natural log of 4 minus 1 plus 3 natural log of 1. So if I simplify this, I get 4 plus 3 natural log of 4 minus 1, but natural log of 1 equals 0, so that will just go away. So really it's 3 plus 3 natural log of 4, or D. Okay, so f prime equals this, and f of 2 equals 4, f of 1 equals. So we'll just set up an integral here. So we know we're going to use the x values that they give us, so 2 and 1. So my integral is going to be from 1 to 2 of 6x squared minus 2x is going to equal f of 2 minus f of 1. That's our first fundamental theorem again. So I'll just take the antiderivative here, and I get 6x cubed over 3, which is 2x cubed, minus 2x squared over 2, so minus x squared, evaluated from 1 to 2. equals 4 minus f of 1. So when I plug these in, I'm going to get 2 times 2 cubed is 8, minus 2 squared is 4, minus 2 minus 1 equals 4 minus f of 1. So if I keep simplifying this, 2 times 4 is going to, 2 times 8 is 16, minus 4 is going to give me 12, minus 1 equals 4 minus f of 1. So 11 equals 4 minus f of 1. 7 equals negative f of 1. So negative 7 equals f of 1. A should be your answer. All right, there's our graph of f prime. They give us f of 2 and f of negative 4. So once again, we're going to set up our definite integral from negative 4 to 2 of f prime of x. And this should just equal f of 2 minus f of negative 4. Now, this is f prime. We're taking the antiderivative of f prime, so it's just going to be area under the curve from negative 4 to 2. So obviously down here, it's going to be a half circle, and it's below the x-axis, so it's going to be negative pi, radius is 2 squared over 2, plus base times height is 2 times 1 over 2. F of 2 is 3 minus f of negative 4. So we just got to simplify this now. This right here, 2 squared is 4. So this is really just going to be negative 2 pi plus 1. Subtract the 3 over. So I have negative 2 pi minus 2 equals negative f of negative 4. Divide everything by a negative and we get 2 pi plus 2 equals f of negative 4. So our answer is A. Okay, 116. So looking at this one, you should know you need u sub because we have a function inside of another function. So I'm going to make u equal to 4x, du equal to 4 dx. But I don't want that 4 there, so I'm going to divide by a 4. So I have 1/4 du equals dx. So then I'm going to have the antiderivative of sine u du. We'll just have a 1/4 on the outside. So when I take the antiderivative, I get 1/4. Antiderivative of sine is negative cosine u plus c. So I should have negative 1/4 cosine of 4x plus c, which makes my answer C. Okay, here's another u sub. So looking at this one, I have to pick which one's going to be my u. So I'm going to pick the one with the higher exponent. So u is going to be negative x squared plus x. Du is going to be negative 2x plus 1. And then if I notice, I want this to equal negative 4x plus 2, so I'm just going to multiply it by a 2. So 2 du equals negative 4x plus 2. Sorry, there should be a dx there. So now everything's going to work out how we want it to. I can set up my integral. So 2, this 4x, negative 4x plus 2 dx is going to become du. And then I'll just have u to the third power du. So then it's going to be u to the fourth over 4 plus c. And all I have to do is just replace it. So 2 times negative x squared plus x to the fourth power over 4 plus c. And then obviously this is just going to become 1/2. So if we look, it looks like it matches D. Okay, 18. So they want us to use u substitution. They tell us which one though. And notice all of our answer choices keep a u. So obviously u equals x minus 1. Du equals 1 dx. So everything we need is almost right, except we're left with this x on the bottom that we need to get rid of. So we're going to have to use that method, or we're going to change this around. So I also know that x equals u plus 1. So I'm going to replace this bottom x with u plus 1, and I'm going to replace this top with square root of u. So when I set my integral, it's going to become square root of u over u plus 1. So I can go ahead and get rid of answer C and answer D. But notice how u is left in my answer choices. That means I'm going to have to change my limits of integration here. So I'll just plug each of them in to see what their u value is. So u equals, if I replace x with 5, 5 should become a 4. And if I replace u with 2, it should become a 1. So 1 to 4, A would be our answer. Uh, 19 and 20. No. So on these, what you would need to do, first off, 120, you have to complete the square. I'm just saying no to that. And what would you do on this one is you would split it up. So you'd have x squared over x minus 5 plus negative x over x minus 5 plus negative 24 over x minus 5. And then you'd have to do all of those separately. And that's just not